Assalamu alaikum students. We were doing about the transition elements in our previous class. So we left at this point where we were studying about the structure of the ligands, and we had discovered that there are different types of the ligands which are present. We discussed about the monodentate ligands, bidentate ligands, and then we ended at the hexadentate ligand, which in this case is a EDTA. Now this table which has different types of the ligands present. We have the water, ammonia, chloride. So some information are given about these ligands. Their formulas are present in this column. Then the formation of the complex by these particular ligands are given in this column, and the coordination number of this particular ligand or this particular complex sign is given in this column, and then we have the shape. And these are the shapes of the complexes. So basically here we can see that water, there are 6 water molecules bonded through dative bond with the iron, and we get this octahedral shape. Again, there is octahedral over here. In this case, we have a tetrahedral shape of the complex sign. Why is it tetrahedral? It is because we have the 4 ligands bonded, and these ligands are occupying large space. That's why the shape is of tetrahedral. And then in this case, we have 4 ligands, but it makes a square planar. So square planar shape is given in this chapter, and the rest are again octahedral. So in majority, we have the octahedral as a shape of the complex sign whenever we have 6. We have coordination number 6 of the central metal line. And these are some of the examples of the ligands which are present. We have these two as the neutral form of the ligands. This one is negatively charged ligand. This one is also negative. This is negative. This is also negative. It is called thiocyanidine. And then we have oxalate ion. And then at the end, we have ethylene, diamine, EN, or 1,2-diaminoethane ligand. After this, we have the topic of the shapes of complex ions. How different types of the shapes are produced by these complex ions. So basically, uh, we have to consider the size of the ligands which are present in the complex, as well as the um, repulsive forces, which keep these ligands apart from each other. As we just saw that the ligands can be negatively charged, so these negatively charged ligands will be repelling each other. So as a result of that, we must have one symmetrical shape of the molecule in which the ligands are present at a perfect shape. So basically, octahedral has this type of the shape. This is a square planar shape. This is tetrahedral shape, which we discussed previously in AS. We also discussed octahedral in AS, and this is square planar, and this one is linear. The example of the linear complex sign is given here. AG is present in the center, and then 2 ligands are bonding on the AG. This is also an example. So a few transition metal ions, example copper one, silver one, gold one, are those complexes which form the linear complexes. We have very few and specific examples for of the linear complexes, and these are the 3 examples given here. You can see from the periodic table that these 3 elements are present within the same group: copper, silver, and gold. After this, we have the stereoisomerism in complex science. The stereoisomerism, which you studied in your AS organic chemistry, where we saw about the 2 types of the isomerism which come under the stereoisomerism. One of which is the geometrical isomerism, and the second one is the optical isomerism. Here we will first discuss about the geometrical isomerism. The geometrical isomerism in the complexes do exist, and these are there because of the presence of the again the positions of the ligands, similar ligands around the central metal ion. For example, if we have, if you can see here, this is an example of a platin complex. The name is platin. The platin compound has platinum at the center and two ammonia ligands and two chlorine ligands, and the shape is square planar. This is called platin. Now, platin can form two geometrical isomers. We have trans and we have cis. In case of trans, the ligands of similar type are present on the opposite diagonal positions. These are diagonally at opposite positions, and you can also see about the chlorine that they are also present at the diagonally opposite positions. Whereas in case of cisplatin, the ammonia molecules are present on one side of the platinum, and chlorine are present on the one other side of the platinum. So this is cisplatin and this is transplatin, and these cis trans are according to the square planar geometry. This is 3D dimension, 3D way of showing the platin, and this one is two-way or two-dimensional representation of the platin. In this case, you can see that uh, the ammonia and ammonia are present on the opposite sides. So this is transplatin. According to 2D dimension, 2D form or representation, the molecules are present on the opposite sides. Whereas in case of in case of cisplatin, they are present like adjacent positions. They are adjacent to each other. So this is cisplatin. Similar for the ammonia, they are adjacent to each other. All right. Uh, so cisplatin and transplatin, we have the similar representation is shown here. Transplatin means they are on the opposite sides, and cisplatin means they are on the one side of the uh, central atom. Now, how about the octahedral molecules? In case of the octahedral molecules, the cis isomer, we first look at the simplified version of the octahedral. We have only two types of the ligands present here. The ligands of A types and then ligands of the B type, which means their chemical uh, the chemical formulae of these two are different. They are chemically different ligands, and these are different from the B. So in case of cis, the presence of the presence of ligands of similar type are on the adjacent positions. You can see that they are present at one side of the platen and they are adjacent to each other. They are not opposite to each other because the opposite direction of this B is basically A. This is the opposite position of this B ligand. If you rotate it other way around, you should get B over here and B over here. Then in that case, that will become transplatin, as you can see here. But you see that this B and this B, they are opposite at their opposite directions. It is totally on the opposite of this direction coming out of the plane, and this one is going into the plane. So this is a transplatin. If you rotate now, if you rotate this molecule in a such a way that B comes over here and this B comes over here, it will become transplatin. But for this case, in case of cisplatin, the similar ligands must have two adjacent position. It can be this B and this B, or it can be this B and this B. it will still be a cisplatin. So you are basically rotating the molecule. So this type of the octahedral geometry is called cisplatin. So we have now more example. Now in this case, the type of the ligands are somewhat different. The ligand H2O and ammonia are here. We should know that the presence of this oxygen in this molecule gives this molecule a partial negative part, because the oxygen has a high electronegative value, which is mentioned here in this paragraph. Or you can also go through the previous cases of this one, in which we studied both the polarities and the presence of the polarities in this type of the complex. The ammonia, within the ammonia, the nitrogen has electronegative value, which is mentioned here, 3.04, and the electronegative value of the oxygen, sorry, the chlorine, the value of chlorine is 3.16. So chlorine is more electronegative than nitrogen. As a result of this, whenever we have a cisplatin, then both two high electronegative atoms are present on one direction. So as a result of this, this side will become sigma negative and the other side will become sigma positive. So there exists a polarity in this case, in the case of the cis form of square planar, the cis isomer of the square planar complex sign. So only in the cis form, when the similar high electronegative ligands are on one side, they will contribute towards a sigma negative charge. So the other side will definitely become sigma positive charge, but not in transform. In case of the transform, the high electronegative ligands are present on the opposite directions. So according to the dipole moments, the arrows of the dipoles, they will cancel out each other, and as a result, their dipoles will be cancelled out. That's why this transplatin or trans geometry or this scape planar is non-polar. Now we will apply the same rule over here in case of the cis and trans of the octahedral. Let's suppose this is the cis form of the octahedral, and we have only two ligands, the H2O and NH3. So just like we said that oxygen is more like electronegative, the value of oxygen atom is 3.16. The value of oxygen atom is 3.16, whereas the value for the nitrogen, is 3.04. 3.16 belong to chlorine, by the way, uh, whereas the value of oxygen is 3.44. Oxygen is 3.44, so I will write here 3.44. The value of nitrogen is 3.04. Now, both the high electronegative atoms, which are basically the oxygen atoms, they are present on one side of this octahedral cis isomer. Oxygen is here and oxygen is here. So both are on at the one direction of the octahedral. As a result of this, we will see a sigma negative side over here. This is a sigma negative side. So more negative side is present on one direction. Whereas in case of the transform of this isomer, the oxygens are present at the opposite directions, at the opposite points. So as a result of this, the dipole moments of these oxygen atoms will be cancelled out, and as a result, no polarities are present here. So it is a non-polar molecule, whereas this one is a polar molecule. And this creates a difference in their chemical reactions. the geometrical isomers in which there are some polarities, they have their different chemical properties as well, which will be depicted in the chemical reactions. We have similar type of the case here. This is a cis isomer in which the now here you can see that OH2 is present here and this H2O. These both are same molecule H2O, the water molecules. If you try to rotate it, then H2O will also come over this point. If you rotate from this position, it can also come over here. So it is still a cis form. But trans is the same in which the water molecules are present totally at opposite directions. I can also place these water molecules on the other points. Like if I say H2O is present here, then the other H2O must be present here. And same goes for the other 2 points. So only in at these points the octahedral the octahedral complex will be trans isomer. Now we have just discussed about the monodentate ligands over here. I can now also include the trans form of the isomer. The trans isomer, I can also include the cis and trans isomer for the bidentate ligand. Now in this case, we have two bidentate ligands and we have two monodentate ligands. It is still a coordination number 6 for the central atom. Coordination number 6 here and coordination number 6 over here. But you can see bidentate ligand is there. Now, in this case, how can we find the cis trans? Now, it is easier to visualize the trans isomer because both the bidentate ligands are at the opposite directions and both the monodentate ligands are at the opposite positions. So that's why it is a trans isomer. And if you want to visualize the cis form, then you can see that both monodentate ligands are on one side of the metal and the other two bidentate ligands are on the opposite ways, but they are on the plane as well as uh, not on the plane parts of these bidentate ligands. So we can see two types of the bondings of the bidentate ligand over here, and same goes for there. So that's how we can visualize the cis and trans isomers in case of the monodentate ligands and bidentate ligands. We'll continue our lecture from this point onward in our next class. Till then, take care and Allah Hafiz everyone.